Hello everyone and welcome. This is Science Visualized, and today we're looking at physical chemistry, where we're going to kind of look at the introduction of the first law of thermodynamics. So in science, we talk about two broad classification of properties. Some of them are called macroscopic, so that deals with large-scale systems. For example, in thermodynamics, we're mostly focused on the macroscopic properties of the system. So we're looking at temperature, heat, energy, work. While in microscopic, we're looking at very small quantities. So we're basically looking at the molecular level, at the atomic level. And that's basically covered under quantum mechanics. In thermodynamics, especially when we're talking about the first law of thermodynamics, we're going to be looking at work. That's the amount of work done by the system or work done on the system. So we're talking about positive and negative work. And then heat, that's the amount of energy transferred into the system or out of the system. And we're also looking at the internal energy. So that's the amount of energy in the system. And that can either increase or decrease depending on whether the system is doing work or work is being done on the system. Internal energy is actually a state function. That means we are basically interested in the initial and final conditions. The opposite of a state function is a path function, so PATH, where it's very important to consider the path followed. So in thermodynamics, we either look at physical or chemical processes, and then we just focus on the initial and final state of the system. Now let's look at work. What is work? Now consider this example where you have an object being moved from this position to this new position, so that now the object is right here. The distance covered is S. Then we can calculate the amount of work done by moving the system from the initial position to the final position, and that's given by force, so the amount of force applied times or multiplied by the distance covered. So that's going to be force times distance, or force times a dot distance. In the case where the amount of force applied and the distance is not linear, then you're going to look at an angle, theta, so that's an angle, and in that case, work equals to force times distance cosine of theta. Thank you very much for your time. We'll continue. Tune in for the next part of the first law of thermodynamics. Please support the channel by subscribing, by liking the videos, and also by commenting.